And I did a careless bonehead thing here. When I put the square root of x here and the square root of x here, then I took this function and put it here, but that's not what it is. This is a composite where f of x is 2 to the x and g of x is the square root of x, right? Sorry, f of x is the square root of x and g of x is 2 to the x, right? So that goes here. F of x is square root of x and g of x is 2 to the x, which means that that function square root of 2 to the x should have gone here, not here. Okay? Because, again, f of x is a square root of x all the way through here. So f of g of x is a square root of g of x, which is, in turn, the square root of 2 to the x. So I wrote it down over here when I should have written it here. Okay. Anyhow, I want to do something else. Let's say f of x equals k times the square root of x. And we denote this by y, okay? If x is 36 and y is 12, what's the value of k? How do you figure that out? Well, you have then y equals k square root of x. We don't need function notation to write this down, right? If this equals this equals this, then this equals this, right? Transitivity of equality. Okay. You don't need to necessarily know that term, but it's a good thing to know. So, if y is 12 and x is 36, this becomes this, right? Does that make sense? If you're given that y is 12 and x is 36, then this immediately gives you this. Okay? So what's k? 2. You can do that in your head. Maybe you did, maybe you didn't, but you can. I'll write it out. This means that 12 equals k times 6. You divide both sides by 6. Okay? Then now we defined our f of x function as 2 square root of x, right? Because it was k square root of x, but now we figured out what k is. We replace k with the 2. Okay? So now I can ask questions about this. I can say, okay, if x equals 49, then what is the value of y? How do you answer the question? Well, the two ways to answer it, y equals 2 times the square root of x, right? And very quickly you figure out that y is 7. Any mystery to that? Okay. So it's fairly straightforward. That's one way to answer the question. You can say y equals f of 7, right? F of x equals 2 square root of x, so y equals 2, and I wrote 7, I should have written 49. X is 49, right? So y equals f of 49. F of x is 2 square root of x, so y is 2 square root of 49, which is 2 times 7, which is 14. Just two different ways to say the same thing, but you want to understand it both ways. It takes a little getting used to, but it's not overly difficult. Okay, it's an unfamiliar notation, a notation maybe you haven't done as much with as you might hope, but it's not difficult if you just understand that, for example, if your f of x function is 2 square root of x, then f of 49 equals 2 square root of 49. Because you replaced x by 49, you have to replace x by 49, right? That's the bottom line. If you replace this by something, you got to replace this by something. That's the same thing. Okay, I want to kind of switch gears. Let's say we've got our pendulum graph. And we have the point 1, let's say your count was 140, so we have the point 1, 140, and we have the point 3, 90. Okay. Then you draw the concave up graph, which will end up looking something like this. Okay, you follow me so far, right? And it turns out that the concave up graph is the only graph, and I kind of missed the points, but pretend it went the graph went through the points, right? And when you draw it, don't miss. Well, you might miss a little bit. It's a question, I think, that was on the homework. It said, between this point and this point, how much did the length of the pendulum change? 2. By 2, right? from the first point, which is this point, to the second point, which is this point, length changes from 1 to 3. That's real obvious because, of course, X is your length, Y is, we'll just say it's your count. Okay? And what we did for anybody who wasn't here, we hung a pendulum up here about this long, we counted it 100 cycles and figured out that it took so many counts per minute. And that's the number we put here, okay? The 1 minute count. And actually I probably ought to say count per minute because we counted 100 counts. Then we took a longer pendulum, and of course a longer pendulum doesn't have as many counts in a minute. You think of the swing as being slower. So a pendulum of length 3 maybe counts 90 per minute, okay? I just made up those numbers. They aren't necessarily accurate for a pendulum, although they're probably not far from being reasonable. Okay? So what we see, this point represents a pendulum of length 1 that has a count of 140 per minute. This represents a pendulum of length 3 that has a count of 90 per minute. Okay? So the length of the pendulum between this point and this point, well, there's the length, there's the length. The length was 1 and now it's 3, so the length changes from 1 to 3. And the count per minute changes from 140 to 90, right? So what's the change in length? Well, somebody said 2, and that's pretty obvious, right? Change from 1 to 3, the change is 2. Now, arithmetic, we take the second and subtract the first. That's how we get the change in something, right? We subtract where we end up from where we started. We subtract where we started from where we end up. There's 2 chalk boxes, as you know, but we'll just go with the numbers for the moment, okay? What's the change in the count per minute? 50. Is it 50? Well, if we start at 140 and change by 50, what do we get? We get 190. We don't get 90. Okay? If we start at 140, in order to get 90, we've got to change by negative 50. That's pretty obvious, right? But you got to be careful about the direction of your change. And again, we take the second count, which is 90, and we subtract the first, and that's exactly what we get. Okay? Now, this is a great big deal because this is the most fundamental idea in calculus. This is pre-calculus. Okay? So we're not going to do calculus with this idea, but we have to understand the idea of a rate of change. And if you read the, material I gave you, incidentally, if you're new to the class, make sure you pick up one of these. You see that the third section here is rates of change. Okay? So I'm going to make a big important statement here. The rate of change of the count per minute rate of change of the count per minute with respect to length is the change in the counts per minute divided by the change in length. Now that's a phrase you should read to yourself 100 times a day for the next week so it rings in your ear. Well, you're not actually going to do that. But you want to really look at this frequently, this statement, okay? The change in the count per minute is negative 50. The change in length is 2. So that rate of change is negative 25. That means that for every unit of change in length, on the average, you're losing 25 counts per minute. You lose 50 pounds per minute when your length changes by 2. Well, you lose 25 for every unit of change. But that's on the average because this isn't a straight line. Now, that's a lot to digest, so we're not going to worry too much about that. But we do want to get this idea of rate of change, and we want to see why the rate of change is defined the way it is in your text. Okay? They give you a simpler definition that doesn't involve a bunch of words, but it constitutes the same thing. So, fundamental triangle. For 2 points, I'll use the right word, legs. Parallel to the x and y axes. I guess I better say line segment. The hypotenuse is a line segment from one point to the other. Okay? Now, the fundamental triangle for these 2 points, well, the hypotenuse is this line segment, right? And you got to have a triangle, and its legs have to be parallel to the coordinate axes, right? So if I start here, which leg do you want to draw? You want to draw a leg above the hypotenuse or below? I'm sorry? Below. Okay. Well, that leg has to be parallel to one of the axes. If it's going to be below the hypotenuse, then it's got to be parallel to the axis that goes down. I say parallel to the hypotenuse. I don't know. Parallel to one of the axes. Okay. It's got to be this way. Now, we could have drawn it this way. We could have drawn it parallel to this axis, right? It's got to be drawn parallel to one axis or the other. It doesn't matter which one, whichever one makes your picture prettier. The other one has to be drawn parallel to the other axis. That gives you a right angle, gives you a right triangle. What's the rise of this segment? Well, the rise is this side. The run is this side, right?
Would the rise be 50?
I'm sorry?
Would the rise be 50 since?
Negative 50 if you go from here to here. But if you want to go from here to here, it could be positive 50. Now, if you go from here to here, then your rise would it'd be rising from here to here, it'd be 50, right? But your run would be from here to here, and that would be -2, wouldn't it? So what you have to do is, it doesn't matter which direction you go, but you have to decide what direction you want to go from point to point. Usually we'll go from left to right, but you get the same thing if you go from right to left. So I'm saying, okay, if we go this direction, then our rise is negative and our run is positive. The rise would be -50, the run would be 2. So what's the slope? What's your definition of slope? Rise divided by run. So we could say slope you get -25, right? So your book defines the rate of change in terms of 2 points on a graph, and the rate of change is the slope between those points. And slope is something you should be very familiar with, but if not, a little practice, it's not a hard concept. Okay? But if you're not real clear on slope, you want to make sure you spend plenty of time becoming clear on it. Okay? Now, you're not going to have a huge amount of time between now and Thursday to do some problems, but I'm going to give you the whole assignment that'll be due next Tuesday, and I'll tell you what part of it will be due on Thursday, okay? Now, I have to leave. I have a chiropractor appointment at 2 o'clock.